Yesterday was a bad day for 3D printing. I spent about 10 to 12 hours trying to get one piece created. I found a front skid with a hole in it for the cooling on the airplane, and it came oriented like this for printing. So it printed without support fine till I went over and pulled it off the build surface. Had all sorts of, it was centered here when they designed it. This was rough. This printed okay. Then I turned it over. Oh my goodness gracious. This is where it was on the build surface, and this was the area that was kind of angled up in here, and it just really missed. So it's just terrible. I wouldn't want that on the front of my airplane and take it to the field and the other club members see it. So I decided, instead of having it print in this orientation, I would lay it over and see what happens. But if you notice, this right here is beveled, so this doesn't actually touch the surface. So I started it printing. I had to go to Black Mountain. I came back to this. This edge got off and just continued to be off. This was a better print when I oriented it flat instead of like this. But again, that beveled angle here, this, I don't understand. I've printed with a less of an angle. This is less than, I don't know, 20-degree angle, but it just messed up and continued to mess up. So when I come back from Black Mountain, I stopped the print. You can see it's not even a whole print. I stopped it, and that was the waste of about 7 hours. So then I just said, I'm going to do what I think is right and cut all this out. So I oriented it actually like this on the build surface, and I told it to use support because of this little area right here, even as small as it is. Put support underneath here to hold it up, and it took about 4 hours to print this one. It came out perfect. I mean, look at the layers. They're just, I almost would use the word pristine. It's a practically perfect print. There's a channel down through here where the part meets with the front nose of the airplane, and then we have the hole for venting. There's another hole here, and then there's another hole down here, a little beveled, for matching up the hole on the front of the fuselage that the others I had. But look at this. This piece printed perfectly. So I learned a lesson yesterday. I've got to quit shying away from using support. The first thought is it's wasted plastic that you have to tear away after a print is printed and throw away. It's just wasted plastic. It's not. If a 4-hour print fails and you have to throw away, this is throwaway. This is more than the support that came off this piece. If you have to throw all this away because it's junk, then quit worrying about the support. When I see stuff like oriented like this, when I drop it into the slicer, I've just got to learn. Rotate it. They didn't design it well. Rotate it, add support, even when it's just a little place that's up off the build surface. Go ahead and print it with support. Lesson learned yesterday. Lesson learned. So the fuselage, as you can see here, has a air hole right here to take in air for cooling. Got one big one up in the top there. So this part matched up with that air hole and has an air hole in the front here so that the cooling can be maintained while putting this on the front of the model. So there, that's finished. That's finished. That should work perfectly. But the moral of the story is, quit sweating support plastic that seems to be waste, because you can end up wasting a whole lot more plastic than the little bit that you're using for support. By the way, this PLA, polylactic acid, this was created back in the 1920s, 1930s, when they found that some fermented turnips, if they mixed lactic acid with it, it created a plastic. I don't even know if they called it plastic back then. I think they might have called it polylactic acid, PLA. So it's moldable and works well in these printers for heating up and extruding. But it melts at about 150 degrees centigrade. It doesn't like water and some other things. So if you leave some of this PLA in the sun, the heat will cause it just to slump. And water can affect it, etc., etc. So polylactic acid is actually a bioplastic. It is biodegradable. Granted, it can stand in seawater for a year and show no signs of degrading. But in an industrial degrader, it can completely be degraded back to plant type material in as little as 3 days. So it's it's almost like it shouldn't be called plastic. It shouldn't be looked at as plastic like all the other forms of plastic we know, for two reasons. Number one, it isn't. It's basically a bioplastic. It's basically made now with cornstarch, flour, those kind of plant celluloids, and lactic acid. And the other thing that shouldn't take for granted is the fact that the plastic really doesn't do well with sunlight. It will slump on you in a heartbeat if you leave it in a hot car, this, that, and the other. So it's not a petroleum type plastic. Those great plastics that don't degrade for like 5,000 years. This is a bioplastic. Not usable in most injection moldings and stuff, but it lends itself well to being made into filament and extruded through a 3D printer very well. So that's the short lesson from yesterday. It took me 10 to 12 hours to get this one piece, but also shows another lesson. If you know something should be able to be printed correctly, whatever you're doing in life, don't give up easily. If you know you should be able to do it, you probably can, with just being persistent. So now I have a pristine piece. I found one with an air cooling hole through it, so cooling gets into the model better. I can repeat print this if I have to, if it breaks and I have to put another one on. So I'm basically finished with this, and should I ever have to reprint it again, it will be in an orientation like this and printed with support, and I'll spend 4 hours on it instead of 12.